Hello everyone, today I'm going to show you how you can solve some type of geometric problems involving prism and its volume. So let's have a look at our task first. The diagonals of adjacent lateral faces led from one vertex of the right regular triangular prism form an angle of 2 alpha. Find the volume of the prism if you know that the length of the edge of the base is equal to A. We are asked to find the volume of the prism drawn below. In that case, let's recall the formula for the volume of a prism. So, volume of any prism is equal to area of its base, which is triangle in our example, times its height, denoted as h in the example. Obviously, we know neither area of the base nor height. So let's determine which variables, which values we already got. Certainly we know the size, the measure of an angle led from common top vertex to opposite vertices on the bottom, which is equal to 2 alpha. So let's draw arms of that angle. Additionally, there's one more piece of information. We know that all three edges of the base are equal to A. So in fact, our triangle is actually equilateral. So our unknown area of the base is equal to equilateral triangle. Let's write it down. So we have to take a closer look at the base, at the triangle. In order to calculate the area of the equilateral triangle, we need to know its height, its altitude, and the length of its base. So let's drop the unknown altitude of the top vertex onto the base. And let's denote it as x. Because our triangle is equilateral, the intersection between height h and the base a divides the base exactly into two equal segments, which are equal to half of a. But we can say even more. The height divides the triangle into two congruent right triangles. And this is a crucial piece of information, because we would like to work out the unknown variable x and express it in terms of given a. And actually we can do it if we recall one of the most important theorems in elementary geometry, which is Pythagorean theorem. It states that in any right triangle with hypotenuse c and the other two legs b and e, the following equation holds. C squared is equal to d squared plus e squared. Or in other words, the Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So we're gonna simply apply this formula to our case, keeping in mind that C from the theorem is now A, D turns into H, and E is exactly equal to half of A. So the formula gives us the following equation. X squared plus half of A squared is equal to A squared. We simply follow the order of math operations. So we raise half of A to the second power. And then we would like to solve the equation for x. That's why we need to leave x squared alone on the left hand side of the equation. So we take off the second term from both sides of the equation, which gives us x squared is equal to a squared minus 1/4 a squared. So we simply take off 1/4 a squared from a squared, or in other words we reduce like terms. And finally we take the square root of both sides of the equation. So we worked out the formula for our unknown variable, for our unknown height x. And now we can compute the area of the triangle. Let's recall the formula for the area of any triangle. It's 1/2 times base times height. So we simply plug our values to the formula. 1/2 times base, which is a, times height, which is square root of 3 over 2 times a. And finally, the area of the equilateral triangle is equal to square root of 3 over 4 times a squared. Let's rewrite it in the top right corner. Now when we worked out the area of the base and expressed it in terms of a, which was given, we can focus on the unknown height of the prism. We can calculate it in a few uncomplicated steps. Let's first note that there is an isosceles triangle which arms are red and which base is green. Let's denote its vertices as A, B and C. Now we bisect its 2 alpha angle. And we got 2 equal angles of alpha. Let's denote intersection between the bisector and the base of the triangle as D. From the fact that ABC is isosceles, we draw a conclusion that a part of the bisector, segment AD, is the height of the isosceles triangle, and it forms right angle with the base. What's more, the intersection D divides the base into 2 equal segments, both of them equal to half A. Now we note that there is a right triangle ADC, which hypotenuse is face diagonal of our prism. Now we're gonna deal with this right triangle only. Let's remind again that hypotenuse of our right triangle is the face diagonal of our original prism, and that opposite side of the right triangle is equal to half A. We need to express unknown face diagonal in terms of alpha and A, which are given. And actually we can do it quite easily if we remember the right angle definition of the sine of an acute angle alpha. Let's say we have a right triangle with an acute angle alpha, hypotenuse C, opposite leg D, and adjacent side E. Then sine of alpha is equal to D over C. This means sine alpha is equal to the length of the opposite side to the length of the hypotenuse. And we simply apply this formula, this definition actually, to the acute angle in our example. Keeping in mind that D, opposite side of the triangle from the theorem, is equal to half A, and C, hypotenuse, becomes our face diagonal. This gives us sine of alpha is equal to A over open bracket 2 times face diagonal close bracket. We're gonna solve this equation for face diagonal. So we multiply both sides of the equation by face diagonal, which gives us sine alpha times face diagonal is equal to A over 2. After that we divide both sides of the equation by sine alpha. As a result we get final expression for the face diagonal, and this is exactly what we were looking for. We expressed face diagonal in terms of A and alpha, which were given. So now when we worked out our phase diagonal of the prism, expressing it in terms of A and alpha, let's note that the phase diagonal divides the face of the prism into two congruent right triangles, and that the hypotenuse of that right triangle is our phase diagonal, and the other two sides, the other two legs, are equal to h and a respectively, where h is the unknown height of the prism we're trying to calculate, and where a is the length of the edge of the prism. So let's have a closer look at that right triangle. And now we would like to compute the unknown variable h by expressing it in terms of a and phase diagonal, which were previously given or calculated. And actually we can do it quite easy if we apply the Pythagorean theorem to our right triangle. So let's remind the theorem states that square root of the hypotenuse is equal to the sum of the squares of the other two sides. So this gives us a squared plus h squared is equal to phase diagonal squared. Now we replace phase diagonal with previously calculated equivalent expression and raise it to the second power. This gives us a squared plus h squared is equal to a squared over open bracket 4 times sine squared of alpha close bracket. Now we would like to leave our unknown variable h alone on the left hand side of the equation. So now we move the first term to the other side of the equation and change its sign. After that we consider a squared as an improper fraction, and we build it by multiplying both numerator and denominator of our improper fraction by the denominator of the other fraction, so that we get common denominator for both fractions. Now we factor out common term from the right hand side of the equation, which is a squared over open bracket 4 times sine squared of alpha close bracket. And finally we take square root of both sides of the equation. This gives us final expression for the previously unknown variable h. Let's rewrite it in the top right corner. So now we are able to calculate the volume of our prism. We know that the formula for the volume of any prism is area of the base times height. In our example, area of the base is actually area of the equilateral triangle, equal to square root of 3 over 4 times a squared times height, which we've just calculated. So let's rewrite it, and this gives us the final solution to our problem.